Welcome to the Explainer. We are jumping straight into an incredibly complex, yet, frankly, absolutely fascinating intersection. We're talking about that exact magical moment where abstract, on-chain digital state reaches out and actually triggers physical execution right here in the real world. We're diving deep into episode 29 of the source materials, and our main character today is ERC-7827. We're going to trace this mind-bending path from a digital root anchored securely on the blockchain all the way out to a physical leaf sitting right on a desk.
Okay, let's kick things off with a pretty wild ideological clash found right in our source documents. So the classic upside-down tree metaphor, exactly how developers have visualized data structures for decades, was officially banned in this architecture, literally classified as apostasy. Sounds intense, right? Why ban a simple metaphor? But more importantly, how does taking this ban concept, properly grounding it, and then reintegrating it actually unlock massive scalable Web3 efficiency?
Well, to get to the bottom of that, here's our roadmap. We'll start with Section 1, enter ERC-7827, version control. Then Section 2, grounding the upside-down tree. Section 3, LIFO and single-entry bookkeeping. Section 4, Kali wrapper and kernel sign. And finally, Section 5, physical execution with Cheerbot.
Let's hit Section 1, enter ERC-7827 version control, bridging on-chain logic and off-chain metadata. We've got to start at the foundation. The real breakthrough here is that ERC-7027 introduces what the docs call value version control. Think of this as a completely new standard for JSON smart contracts. Now, usually JSON is just this lightweight data format we use to zip text back and forth across the web. But here, it's acting as a smart contract layer. It enables bit-perfect tracking of state transitions, meaning a flawless mathematical record of every single change while keeping everything in a totally human-readable format. The sources really stress that this is an iterative, pragmatic upgrade to what we already have. It's not some pie-in-the-sky utopian replacement that forces everyone to migrate to a brand new blockchain.
And that pragmatic approach is exactly why this is a massive game changer for everyday developers. First of all, ERC-7827 is 100% backwards compatible with the ERC-721 and ERC-1155 NFT standards we're all already using. But the real magic, it is specifically designed to make Ethereum RPC calls, which, let's be honest, is an incredibly clunky, complex way for computers to talk to the blockchain, as easy as standard REST calls. It brings high data availability directly to the client side. This drastically lowers the barrier to entry, giving mainstream web developers the familiar tools they need to finally cross over into Web3 without needing to learn a completely alien paradigm. Which brings us to Section 2, grounding the upside-down tree from apostasy to architecture. Let's look at why this visual caused such a stir.
Our source documents drop a rather intense directive. They explicitly banish that floating upside-down tree metaphor, straight up labeling it apostasy. Instead, this architecture demands a strict, grounded focus on two very specific things: sovereign stewardship anchored securely at the root, and concrete execution happening way out at the edge, which they call leaf node logistics. The core philosophy here is you can't just float off in the digital ether. You've got to be deeply, securely anchored to reality.
But here is where it gets incredibly fascinating. While the sources purge that floating inversion metaphor, they also reveal a brilliant efficiency when you properly ground it. If we look at massive complex operations like, say, ecosystem-wide airdrops, reintegrating the dynamic of a leaf aggregating to a root hash is the master key. It shows us exactly how thousands of scattered actions out at the edge, the leaves, can efficiently flow back down the trunk to be securely verified by the main contract, the root. It's just an incredibly elegant way to process scattered, real-world data securely.
Moving right along to Section 3, LIFO and single-entry bookkeeping, re-engineering the root. Because to make that precise aggregation actually work, we need to look at the exact data structure holding it together. Initially, there was this widespread rumor in the ecosystem describing an on-chain FIFO, first in, first out, no SQL tree. But our source materials highlight what they call an ultimate recalibration. The architecture strictly pivots to a LIFO, last in, first out, structure for the JSON state contract. And honestly, this isn't just some minor technical tweak. It's a fundamental shift that rewires everything about how we read and verify data on-chain. Because the very last item to go in is the first item to come out, you unlock incredibly efficient single-entry bookkeeping. You only ever need to query index 0 to get an immediate proof of state. Plus, simply checking the version length definitively tells you right away if a digital promise is open or closed.
This enables highly efficient Boolean-style accounting. If you aren't familiar with that term, think of Boolean accounting like an ancient tamper-proof clay seal used for ledgers way back in antiquity. By using LIFO, we are recreating that perfect tamper-proof seal digitally, completely bypassing the need to painstakingly scan through massive, expensive transaction histories just to figure out the current state of affairs. Okay, on to Section 4, Kali wrapper and kernel sign, tracking the record of sweat. With our root securely anchored by that LIFO structure, let's travel up the trunk. Before any off-chain physical action can reliably happen, it's got to be legally and structurally defined. Now, the sources explicitly correct a common hallucination here. It is not keys wrapper. Actually, scratch that. It is Kali wrapper, K-A-L-I. This is a vital protocol used for legally wrapping real-world entities directly into smart contracts, giving them a verifiable, legally binding identity on-chain. Once the entity is legally wrapped, it needs to do some work. This is where kernel sign enters the chat, powering what the documents call the signature economy. By utilizing ENS attestations and cryptographic signatures, kernel sign tracks the actual physical human effort expended. It creates a permanent, verifiable history, what the sources brilliantly call a record of sweat. I love that term. It proves mathematically that real human work actually took place out there at the leaf nodes. It's a wonderfully visceral way to describe cryptographic data, grounding it right back in human effort. And this framing beautifully illustrates the divide and the connection between these worlds. The sources use this framework called cosmolocal. The Cosmo is the global internet. This is where our high-level JSON states and complex RPC calls are floating around in the digital ether. The local, on the other hand, is the internet, our physical, localized, tangible edge devices. So our LIFO roots are anchored securely in the Cosmo, but our execution leaves live entirely in the local. Which brings us to our final stop, Section 5, Physical Execution with Cheerbot, where the leaf nodes finally come alive. This is the exact moment the digital and physical worlds collide. Meet Cheerbot. The sources describe it as a free and open-source alternative to an Amazon Echo. It's this single-board, collectible server that honestly looks pretty cheerful and unassuming sitting on a desk. But functionally, it acts as a very serious physical switchboard. It sits there, reads the on-chain LIFO tree and those ENS signatures we just covered, and patiently waits for a verified state change to happen. Inside that friendly little Cheerbot shell is a Raspberry Pi acting as a localized microhost. When the JSON state contract registers a valid update, say a payment or a tip from an audience member, the Cheerbot reads that bit-perfect version control and triggers the physical GPIO pins on the Raspberry Pi. If you don't know, GPIO pins are essentially just little metal prongs that send out electrical signals. They literally translate code into reality. They physically react in the real world, maybe by turning on a light, moving a tiny motor, or even speaking a custom message into the room. Let's take a second to recap how this entire beautiful flow builds together. Step 1. The LIFO root hash in JSON state securely anchors our data on-chain. Step 2, the legal entity is defined by Kali wrapper. Step 3, the human effort is signed and verified via kernel sign's record of sweat. And finally, Step 4, that verified on-chain action trickles all the way down and triggers physical leaf execution through the Cheerbot's electrical GPIO pins. And there's a quote from the documentation that just beautifully summarizes this entire philosophical architecture. It clarifies that AI agents, like the mentioned Polycritus agent cell, are really just deterministic scripters. The human pilot applies the intent, but the agentic cell executes the sweat. Bridging that massive gap between messy human desire and strict deterministic machine execution is what they call the semiotic bridge. So, as we wrap up this explainer, I want you to really consider the sheer magnitude of this shift. We have moved from abstract, purely theoretical blockchain state to a LIFO-grounded, root-to-leaf architecture that can literally sit right there on your desk and physically react to the digital universe. The technology is here. The semiotic bridge is completely built. The only question left is, when these bit-perfect promises start orchestrating reality in your own living room, what are you going to program them to do? Thanks for joining me on this deep dive. See you next time.